Type O resists malaria. Type A fights cholera. Your blood type is an ancient survival strategy. There are 8 common blood types, but no one knows exactly why they exist. Before the year 1900, doctors had no idea that blood came in different types. Transfusions were essentially gambling with a patient's life. Today we know that your blood type is determined by antigens on the surface of your red blood cells. But the deeper question remains: why did evolution create different blood types in the first place? The answer appears to be disease. Each blood type offers different resistance to different pathogens. Your blood type is not random. It is the result of millions of years of humans fighting deadly infections. Blood types are defined by sugar molecules called antigens that sit on the surface of red blood cells. Type A blood has A antigens. Type B has B antigens. Type AB has both. Type O has neither. Your immune system produces antibodies against the antigens you do not have. Type A blood makes anti-B antibodies. Type B makes anti-A antibodies. Type O makes both. This is why transfusion compatibility matters. If you give type A blood to a type B patient, the anti-A antibodies attack the donor cells, triggering a potentially fatal immune reaction called a hemolytic transfusion reaction. The ABO system was discovered by Karl Landsteiner in 1901, and it earned him the Nobel Prize in 1930. Type O blood provides significant resistance to severe malaria. The malaria parasite Plasmodium falciparum invades red blood cells and causes them to clump together, blocking blood vessels. In type A and type B blood, the parasite creates proteins that bind to those A and B antigens, making the clumping worse. Type O cells lack these antigens entirely, so the clumping is reduced by up to 66%. Studies in sub-Saharan Africa, where malaria kills over 600,000 people per year, show that type O is the most common blood type, found in 50 to 60% of the population. In regions without malaria pressure, like Northern Europe, type A is more common. Natural selection has literally shaped blood type distribution around the malaria belt. Each blood type offers different disease advantages. Type A individuals have stronger immune responses to certain bacterial infections, including cholera. A 2015 study in the journal Nature Genetics found that type A was associated with lower risk of severe cholera infection in Bangladesh. Type B blood may offer protection against certain strains of E. coli and plague. Historically, type B is most common in Central Asia, where plague outbreaks were frequent for centuries. Type AB individuals produce no ABO antibodies, making them universal plasma donors. But they are also more susceptible to cardiovascular disease, with a 23% higher risk of heart disease compared to type O. Each type represents a different survival trade-off shaped by regional disease pressures. Beyond ABO, the Rh factor adds another layer. Rh positive means your red blood cells carry the Rhd antigen. About 85% of people are Rh positive. The remaining 15% are Rh negative, and the evolutionary reason is still debated. One hypothesis links Rh negative blood to resistance against Toxoplasma gondii, a parasite carried by cats that infects roughly 30% of the global population. Some studies suggest Rh negative individuals experience fewer severe symptoms from Toxoplasma infection. But the most striking pattern is geographic. Rh negative blood is most common among the Basque people of Spain and France, at nearly 35%, compared to less than 1% in East Asian populations. This extreme variation suggests strong regional selection pressure that we have not yet fully identified. If you found this fascinating, subscribe to Curious Science for more answers to questions your body already knows.